Today we're going to go through an example of writing loops to solve a problem that you had on your homework a while ago. So we're going to write a function called AtoB that takes as input a matrix A and outputs a matrix B. So how are we going to build that matrix B? Well, the entry in the kth row, jth column of B will be the element from the jth row, kth column of A. And we're going to use loops for this. What we're actually creating is the transpose of A. So B is going to be holding the transpose of A, but we're not going to use the MATLAB built-in functions to do that because we want to practice our loop skills. So this is going to be a function, so let's start off by writing the word function. Put our output variable here equals the name of our function and the input. This is where our function is going to end up. And I want to just draw out really quick kind of the idea behind this function and what we're actually going to be computing. So what the statement is saying is that we want the element in the kth row, so the kth row, jth column of B to be the same element that was in the jth row, kth column of A. So you notice that we're swapping the elements here, or we're swapping the indices of each element. Now I'm going to illustrate this with an example, but our function is going to work for any matrix that we input. But I'll show you a quick example of what this means is going to happen. If A is the matrix 1, 2, 3, 4, 5, 6, let's first notice that this is a 3 by 2 matrix. That's going to come up in a second. Now, I want to create this matrix B, and the way I'm going to do that is I'm going to look at different values of J and K and figure out what location they should end up in my matrix B. So let's see when J equals 1, K equals 1, well that means I'm in the first row, first column of A. So that's telling me I want the element 1 here. And that's going to go in the first row, first column of B. So this one wasn't super interesting because J and K were the same. Let's look at an example when J and K are different. When J is 1 and K is 2, well this means I'm in the first row, second column of A. So first row, second column, that's the 2 there in A. And I want to put that in the location, the second row, first column of B, which is right there. Let's look at the second row here. So when J is 2 and K is 1, that's going to be the second row of A, first column, which is this 3 here. And I'm going to place that in the first row of B, second column. So that's going to go there. When J is 2 and K is 2 as well, we're going to be in the second row, second column of A, and that's going to go in the second row, second column of B. And then when we fill in the rest, we'll have 5 and 6 here. And the hint that we've gotten from the problem is that this J and K variable here, these are going to be our loop indices. We're going to have 2 loops here. We need one loop that's going over J. So here you see J is 1, and then J is 2, and then J will be 3. And then we need a loop that's going over K. So notice that K goes from 1 to 2, and then 1 to 2. And these ending values that they have will depend on the size of the matrix A. Okay. So we need to know the size of A to get started. So I'm going to use the size command, size A. So M is storing the number of rows, and N is storing the number of columns in A. I'm going to do some for loops, but the bulk of my for loop is going to be that B, K, J is equal to A, J, K. That's the bulk of my code here, but I need to surround it with the appropriate for loops. Okay, so let's look over here at our example. I'll write out the last couple values here. So when J is 3 and K is 1, that's the third row, first column of A. That's going to go in the first row, third column of B. When J is 3 and K is 2, this will be the value 6 here. So the third row, second column of A is going to go in the second row, third column of B. So let's notice what our variables are doing, what our loop variables are doing. J kind of stays the same for a little while. It's 1, and then it's 1, and then it's 2, and then it's 2, and then it's 3, and then it's 3. So J is going to be our outer loop in this example. So I'm going to say for J equals, the first value that J takes on is 1 because that's the first, that's how we index the first element of a matrix, or the first index that we're allowed to use for a matrix or a vector is 1. And we want to go all the way to the number of rows of A. So notice that we loop, J goes over 1, 2, and 3. That's how many rows are in A. The variable we have that's storing the number of rows of A is M. So we want J to go from 1 to M. All right. Now, each time, so see that J is fixed here, and then we loop over K kind of inside that. With J staying the same, K is changing. So that's why we're going to put K as our inner loop here. And so we're going to have for K equals 1, 2. The value that we want to stop here is the number of columns. So K is going through the number of columns that we have. And the variable we have that's storing that is N. Okay. And I'm going to end my loops. And that's pretty much the majority of the code. We still have a little orange squiggly line here that says MATLAB is warning us the variable B appears to be changing size on every loop iteration. Consider pre-allocating for speed. So this is just telling us that the matrix B is changing size. So if we can, maybe we should make a matrix of zeros first, and then this would just be replacing those zeros rather than making B larger at every step. So if we wanted to initialize B, we could say B is going to be zeros, and then the size that B is going to end up as. Well, in our example, we had a 3 by 2 matrix, and the transpose ended up being a 2 by 3 matrix. So since we're switching all the indices, in our variables here, B is going to have a size of N by M, because A had a size M by N. And this is it. So we're going to save our function, A to B, and we can try it out. We can try it out with any matrix, actually. So not just this example, but any matrix we want. So I'm just going to use the magic matrix here. And B equals A to B A. I do indeed get the transpose. So notice that this first row here is now in the first column of B. The second row here is now in the second column of B, etc. And this will work for any matrix that we put into our function here. Okay, so that's how you do this with a for loop, and I want to show you how to convert this into a while loop. So let me clear this. Okay, if you wanted to use a while loop instead, here's what we would have to change. So we would no longer have this. So instead of saying for J going from 1 to M, we want J to start at 1. So we would put initialize J here. So initialize J. And in our while loop, we would say while J is less than or equal to M. Remember, for a while loop, we have to have a condition here. We cannot have a vector here because that doesn't make sense. MATLAB is going to get upset about that. So we need a condition, or like a question that is being asked. MATLAB is going to ask this question. If it's true, it'll compute the rest of the loop. If it's false, the loop will end. Okay, and since this outside loop is controlling J, we want to update J at the very end of this loop. So this end corresponds to this while. So right before we end the loop, we're going to update J. And this ensures that our loop will stop at some point, because at some point J will be greater than M and the loop will end. Okay, we need to do a similar thing for K. So here we would have while K is less than or equal to N. And at the end of this loop, we would need to update K. So notice we have to update K inside the loop that it corresponds to. So K is corresponding to this loop inside here, so this is where we should update it. Now the only question is, so MATLAB is getting a little upset because K has not been defined before this loop. So we need to initialize K, and the place I'm going to initialize it is here. Now your first thought might be to initialize it up here, But if we do that, then k will not restart every time we update j. And that's what we want. We want, like, when j is 3, we need k to restart again so that we can go from the first column to the second column to the third column. And then when j is 4, we need to restart again so that k goes from 1 to 3, or however many columns there are. Okay, so the adjustments we had to make from a for loop to a while loop was initializing our loop variable, changing this to a condition, and updating our loop variable. So with a for loop, those things happen automatically. Our loop variable gets initialized and updated, and it's stored in a vector, so we don't need a condition. So the for loops kind of do a lot of those things for us. The while loop, we just need to add those extra elements in here so that this is going to work. So if I save this and I try it again, let's try a different matrix. So I'm going to do b equals a to b, a. And, oh, this is a symmetric matrix, so that wasn't a good example. Let's do a magic matrix again. Sorry about that. B equals a to b, a. There we go. So now the first row is in the first column. Awesome. So this is how you solve that problem from the homework, and how you can try to convert some for loops to while loops. If you have any additional questions, let me know.